when a problem comes in voltage series feedback, first thing, the voltage gain will be always less than 1. This is maybe for common collector amplifier or common drain amplifier, whatever be that, the voltage gain will be unity. That one you have to see. And the input resistance for FET, it is infinity. Okay, for BJT, after feedback, the input resistance RIF should be larger because RIF equal to RI into D. So it is product of RI and D, right? So RIF will be very much large when you compare the value with RI. And output resistance, actual value is 7.35, but after feedback, it will reduce to 816.2. So R naught F dash should decrease from R naught F because you know R naught F dash equal to R naught F, R naught F dash equal to R naught F parallel to RL. So you know this is the combination, right? So definitely whatever value of R naught F you get, it will be reduced when you compute R naught F dash. So these things you can cross check, and once you find that these results are matching, then your design is going to be perfect. Okay, so the design will become perfect, and when you simulate these amplifiers using any online simulation software, you will get a perfect amplification happening in the simulation environment. Okay. So any queries in the problem, just we are applying the formulas and substituting numerical values and getting the answers. And one extra step what I taught you is how to verify whether the answers whatever you get is correct or not. That you can do it even after completing the design of your question. So any queries in the question you can ask. I'll pause for a few seconds. Okay, assuming that things are clear.